Okay, so what we're going to do today is change things up a little bit. We're going to start measuring our solids a different way. So far, what we've been doing is taking all of the concepts from chapter 11 and putting them in a three-dimensional setting. So like for this prism right here that has a rectangular base 3 by 4 and a height of 2, what we did was we found the area of each face and then we just added those together. So same thing as chapter 11, just now in 3 dimensions. In this section, what we're going to start doing is measuring something from a different point of view. Now we're going to measure the amount of space that our solids are going to take up. The way we do that is we try to count how many cubes could fit into our solid versus with area, we're looking at how many squares fit into a two-dimensional setting. So if I'm looking at this prism here, as I mentioned, it's a rectangular prism. The base is 3 by 4 and the height is a 2. What we could do is divide each part of this into the units. So there's the 3-foot part. We could cut that off into 1, 1, and 1. The 4-foot part, same story, and same with the 2-foot part. If we did that, we would slice this thing into cubes. So I have 1 cube here, another one there, another one here, and I could basically count each and every one of these cubes. The sum of those cubes, that would tell me what the volume of this thing is. And so that's what volume is. Volume measures the amount of cubes that fit into a solid space, into a three-dimensional setting. So let's count all these cubes. Okay, so I have 2 rows. I've got a row on top and a row on bottom. Let me count the ones on top. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Hopefully you can see my cursor of my mouse there. And then, okay, so I have 12 cubes in my top row, and the bottom row is an exact copy. So altogether, I should have 24 cubes. So we would say that the volume of this rectangular prism would be 24 cubic feet. So now we're going to have feet with a little 3, kind of like an exponent, versus feet with a little 2. That's with area. Area counts squares that fit into a two-dimensional region. Volume counts the cubes that fit into a three-dimensional space. So let's try to come up with maybe a general formula that's always going to work with your prisms. Okay, so I'm going to go ahead and share a different part here. Hopefully this is showing up. So here they're asking us to find the volume of each prism below. Okay, so let's come up with that general formula that works for any prism. If we think of that last example, 3 by 4 by 5, I'm going to sort of draw in some dotted lines here. I could try to do the same thing here, where I cut this into 2 units, and then this into 3, and then this one into 5, and then I can count all those cubes if I wanted to, but that takes a long time. And the whole goal is to find shorter, easier ways to do that. So notice that we included the height in that thing. And on that last one, we got 24. Just as a reminder, it was 2, 3, 4. That was our prism, something kind of like that. I know that's little, but you get the idea. Instead of dividing that all up into units on each edge and then counting the cubes, what I could have done is, if you notice, we got 24 feet cubed. That's the same as 3 times 4 times 2. Okay, now a lot of you are going, oh, I know what volume is. I learned it in middle school, length times width times height. Okay, that only works actually for one type of prism. That doesn't work for every prism. Our general formula, this 3 times 4, that's the area of our base. And that 2 was the height of our prism. So this right here is actually going to be our general formula for any kind of prism. Don't think of it as length times width times height, because that only works for one type of prism. That will not work for this prism over here. So our general formula would be volume for a prism equals area of base times height. So this is our formula for any prism. That's always going to be our volume. So volume of a prism. So the 2 things we need the area of our base. We also need to find the height of our prism. That's not quite the same thing as what we might think it is. So over here, let's think about that. Our base is this rectangle. So the area of our base is going to be 2 times 3, that's 6 square feet. The height is 5, and so volume is going to be 6 times 5, 30, and then this measurement needs to be cubic. It cannot be squared because we're not counting squares anymore. We're counting how many cubes are going to fit into this thing. And again, if you did that, if you divided this into units, so look something kind of like this, and then this one fives, what you're going to see is all these cross sections of this thing, and you can count all those cubes. You're going to come out with 30 of them. You can do it the long way, or you can do it this way by finding area of base times height. Okay, so let's look at this prism right here on the right. First, we need to identify what type of prism. I know a lot of us are wanting to just jump to our calculators, start plugging things in. You need to identify what is it that we're working with. This should be a triangular prism. It's triangular because the bases are triangles. The base isn't always the bottom. I've said this before, and I'll say it again. The base of a prism has to do with which two faces are both parallel and congruent. So here we have a triangular prism, which means my base is a triangle. My base is not a rectangle. So when I'm finding the area of my base, I am not going to do 12 times 11. So I'll write that down, 11 times 12. Don't do that. That's bad. That's the wrong idea because your base isn't a rectangle. Your base is this triangle here. Area of your base needs to be half of 12 times 10. Okay, so let's see. That's going to be 60 square centimeters. Now, the height of our prism. I know a lot of you will be very tempted to say the height is 10. No, the height is not 10. I'll write that down too. Height equals 10. I don't think so. Bad idea. The reason why the height is not 10 is because for prisms, the height is how far apart are your bases. Since this is a triangular prism, we want to see how far apart are those triangles. Well, those triangles are 11 centimeters apart. H equals 11. Okay, so now that we have area of base and we have height, we have everything we need for volume. So that's 60 times 11, 660 centimeters cubed, not squared, cubed. Okay, so that's it for this video. I'm going to go ahead and post some more videos with worked out examples of some more prisms, and we'll also look at cylinders.